Let's do checkpoint 6.26. They want us to assume that f of xy, which is equal to x minus 1 squared times y plus 1 squared times x, is a potential function for the vector field f. And so that's the vector field. And then they want us to calculate the integral, the line integral, where c is the lower half of the circle oriented in the counterclockwise direction. Well, if we know the potential function, that means f is equal to the gradient of little f. And if we are going to integrate line integral over a curve C of this vector field, which is the gradient, which is a gradient field, according to the fundamental theorem of line integrals, this will simply equal to the original function, that's the potential function, evaluated at the endpoint of your curve C minus that function evaluate at the start point of C. So we don't need to parameterize and do the definition of the line integral formula. We simply need to use this theorem. And since we have our potential function already given to us, we simply need to figure out what our start point and our end point are. So the start point, if this is going counterclockwise means we're going in this direction. And this will be the start point, and this would be the end point. So the start point is the point -1, 0, and the end point is +1, 0. Let's rewrite that. Start -1, 0, and end at +1, 0. Okay. Now, according to the fundamental theorem of line integrals, our line integral for this particular vector field, which is again a gradient field over the curve C, will simply be equal to the function evaluated at the endpoint minus the function evaluated at the start point. And by function, I mean the potential function. And so our potential function is given here. This will be +1 minus 1 squared times 0. So x is 1, y is 0, plus y is 0, plus 1 squared times x is 1. So this is your end point, and your start point is going to be an x, which is a -1, minus 1 squared times y, which is 0 again, plus y, which is 0, plus 1 squared times x is equal to -1. Okay, you just need to be careful about simplifying, but that's all we need to do. So this is 0, this is 0, and we will have a +1 minus a -1. So that gives us 2. All right. We can verify at least that this is positive if you look at the tangent vectors to the curve and compare them with the vector field. A lot of the vector field vectors will be going along the same lines or an acute angle with the vector field with a tangent line. So maybe except for here, the start point up to maybe a small portion here, that we have obtuse angles, but beyond that you have acute angles, and so the dot product of the vector field and those tangents will be positive, and so we're going to get a positive result. Anyways, that's just a quick observation to verify that you do have a positive value. All right, I hope that helps. And we use the fundamental theorem of line integrals here.